Well, LSO is a technology we came in, we were made aware of in about 1990, and it was invented by Chuck Melcher, who now presently works here. At the time, it was so expensive. Again, it was one of those cases where everybody else said it's no good because you can never make it practical. It can never be made commercial because it's too expensive and rare. But it was such a good material that we knew that if we could get the cost down and learn how to make it, that it would be a breakthrough for medical imaging.
So in the late 80s, I was working in the geophysical exploration field, developing cylinder crystals for geophysical exploration, and developed this new material called LSO. And it turned out that it really captured the attention of the people in the medical imaging arena, because it had nearly the ideal combination of properties that are necessary in PET. It has high light output, it has high density, and it's fast. There's a big leap from the research stage to the commercialization of a material like this. This process is commonly called a crystal pulling technique. You're starting with liquid and you want to turn it into a solid, and so you want everything to happen very slowly and evenly and perfectly, because you're trying to get all the atoms in this melted material that are swirling around in some random fashion to all line up and form a perfect crystal. And so the temperature has to be controlled very precisely, and the rate of the pulling has to be controlled very precisely, and the power to the furnace has to be controlled very precisely. And so all this is automated, of course, by a computer that is constantly monitoring the crystal growth. And not only is the crystal growth process very automated, the crystal processing is very automated, in the sense that we take the boule as it comes out of the furnace, and we cut it with automated saws, and because we're cutting upwards of 30,000 pieces per tomograph. And so by necessity, we've developed some highly automated cutting techniques for processing this large amount of material. Once the pixels are cut, then as the robot picks them up, it inspects each and every pixel. And so the robotic arm comes and picks up the individual pixel, holds it up to a camera, which takes a picture of it, and that picture is used to determine if the dimensions of the pixel are within specifications. And then if it's not, then the robot will automatically reject that and go on to the next pixel. So there's 100% testing of the dimensional tolerances of the pixels. And then once the detector is assembled, there's 100% testing of the scintillation signal from the pixels, so that there's a guarantee that there are no dead spots in the pixel. So there's a guarantee that 100% of the pixels in the detector are working and producing the signals that they should produce. The crystals are really sort of the heart and soul of the scanner in a way, because there's such a direct connection between their properties and the scanner performance.
The LSO technology is really revolutionizing PET and thereby also PET-CT imaging. That is, LSO is a crystal detector material that can take a very, very high count rate. That is, it can take a lot of impulses and register them appropriately and correctly. So you can now, in a much shorter time, obtain images that used to take about 40 minutes. For the LSO system alone, you can complete a whole body scan in 15 to 20 minutes, which is, again, a great advantage for the patients and also for the healthcare system, because reduced time required for a diagnostic procedure, of course, saves healthcare expenditures.
So this means that the scans will cost much less and will be affordable by many more people. And that's one of our goals, is to get this technology out to people.